Hello and welcome back to Math Class in Session. Here we organize all of our quadratics into families. The family of quadratics with a vertex at hk looks like this. Y equals a, x minus h squared plus k. Notice how we change the sign and leave the sign because the vertex is at hk, and this says minus h. The family of quadratics with x-intercepts given as r0 and s0 is a times x minus r times x minus s. Again, this says minus r, so the sign will be opposite in the bracket than it is in the given x-intercept. And the last family, the family of quadratics with y-intercepts 0c. This family of quadratics has y-intercept 0c. Notice that the constant term of a polynomial is the y-intercept. This constant term on the end of all the polynomials is the y-intercept. Let's make use of this with some examples so that you can see how these quadratics are organized into these three families. Example. Find the equation of the parabola with given x-intercepts as 2 and minus 3 that passes through a given point 5, 6. Solution. Since we're given the x-intercepts, we'll use the family with the x-intercepts r and s. That would be this family. Now we know that the x-intercepts are 2 and minus 3, so this will be x minus 2 and x subtract negative 3, which is x plus 3. And it looks like that. Now the thing is, all we need to do is find out what a is. And to do that, we'll sub in this point 5, 6. So y will be 6 and x will be 5. Simplifying, 5 minus 2 and 5 plus 3. Again, simplifying, 8 times 3 is 24. Dividing by 24 and reducing. A is a quarter. And so we have our equation. We'll just go back to this, and we'll put in 1/4 for a. So we claim that the equation of the parabola with x-intercepts 2 and minus 3 that passes through this point is this equation. Well, let's just see. On the software, I've carried the example forward. This is the parabola, according to the software. Y equals 1/4 x minus 2 times x plus 3. Now let's just see. Does it have x-intercepts 2 and 3? There's 2, 2, 0, and there's negative 3. So it has the right x-intercepts. Does it pass through the point 5, 6? Let's see. There's the point 5, 6. So yes, that's the parabola that fits the bill. Let's do another example. Find the equation of the parabola with a given vertex that passes through a given point. Solution, use the family with a vertex at hk because we were given the vertex. And so this is the family. Y equals a times x minus h squared plus k. Now into this we have to plug in our vertex, 8 minus 5. So it'll say x minus 8 squared minus 5. Checking, we look at this, and when we state the vertex of this, we would change the sign, leave the sign. It's a good motto when stating the vertex. Change the sign, leave the sign. So if someone was asked, what's the vertex of this parabola, one would say 8 minus 5, which is what we want. Now, to find out what a is, all we need to do is plug this point in. Y will be 3. Y will be 3, x will be 6. Doing the arithmetic, 6 minus 8 is negative 2. Negative 2 squared is 4, so this will say 3 equals 4a minus 5. Dragging the minus 5 over, making it plus 5, and then dividing by 4. So plus 5, 3 plus 5 is this 8, and now dividing by 4, a equals 2. So now we have here the equation of the parabola with the given vertex And if a equals 2, that will pass through the point 6, 3 as required. So the equation is y equals 2 times x minus 8 squared minus 5. Checking on the software. The software graph of y equals 2 times x minus 8 squared minus 5 is as shown. Now I brought the example forward so that we could refer to it. Does this have a vertex at 8 minus 5? Well, according to algebra, it does. And there it is there, the vertex, 8 minus 5. Does this pass through the point 6, 3? Well, let's just see. There's the point 6, 3. So yes, it does that. So that's the correct parabola, and it does fit the bill. Let's go again. Find the equation of the parabola that passes through a couple of given points with a given y-intercept of 5. So the solution here is we'll have to use the family with the set y-intercept at 0, c. That's this family, but we know that c is going to be 5, so we can put 5 in there for c. And now we'll plug the points in one at a time, separately. Sub the points in separately. We can start with negative 4, 37. Now 37 goes in for y, right here for y, 37. And negative 4 is going in for x. So it'll be negative 4 squared plus b times negative 4. I'm plugging them in here because there's a 5 on the end. So plugging this point in and simplifying. So this will be 16a minus 4b, and the 5 will come over and join with the 37 and make 32. Doing it all again with this point, y will be 2, x will be 3, but 3 squared plus 3b. 3 squared, of course, is 9, and 3b, the 5 comes over and joins with the 2 to make minus 3. Now we have two equations and two unknowns, a and b, and so we have to go back to grade 10 and do elimination. So taking this equation and dividing through by 4 because we can, and taking this equation and dividing through by 3 because we can, examine. This process called elimination works when the constant terms are lined up, the equal signs are lined up, the a terms are lined up, and the b terms are lined up. It's lined up for elimination. Now, provided the coefficient on at least one of the variables is constant, or if not perfectly constant, at least the same absolute value, which is what's happening here. We have a negative 1b, we have a positive 1b. So we can draw a line here and eliminate those b's by adding, because minus b plus b is nothing but vapor. Performing the operation of addition, 8 plus minus 1, 4a plus 3a, we have 7 equals 7a, so a equals 1. Now we can take our a equals 1 and substitute it back into any of the linear equations. We could put it into here, we could put it into here, we could put it into either one of those two. I chose this one. 8 equals 4a minus b, subbing in 1. 8 equals 4 times 1 minus b. Solving for b, b equals minus 4. So we have our a and we have our b. And we have our template into which we will place our a and b. So the equation is 1x squared minus 4b plus 5. On the software, bringing the entire example forward to see if it's right. Here's the example, here's our solution, and this is what the software said. Let's see. Does this go through minus 437? Well, I made the vertical scale count by 5 so that we could get to 37. Let's just see, minus 437. Yep, there it is. Minus 437. Does it go through 3, 2? Let's just see. 3, 2. Yep, there it is. 3, 2. And finally, does it have a y-intercept of 5? Yes, it does. It has a y-intercept of 5. So this is the parabola that fits the bill, that solves the example. A final example, find the equation of a parabola with given x-intercepts. Now these are x-intercepts that are compound in nature, meaning there's more than one term in them. 2 minus root 5 is a single x-intercept, and 2 plus root 5 is a single x-intercept. It just has two terms. It's called a compound coordinate. And this parabola has to pass through a given point, say 1, 8. Okay, so we'll choose the family that has the given x-intercepts at r and s, and that's this family. And what we need to do is say x subtract one of the roots, and x subtract the other one of the roots, and plug them in. So it's x subtract one of the roots, and x subtract the other one of the roots. Well, we've got too many brackets here, so we can distribute this subtraction over these brackets, and it becomes minus 2 plus root 5. This one becomes minus 2 minus root 5 because we distribute subtraction over the brackets. Now we've reduced the number of brackets, we have to multiply them out. It will be 3 terms times 3 terms. So I would expect 9 terms all in a row. It will be x times each. It will be minus 2 times each. It will be plus root 5 times each. Checking. X times x is x squared, x times minus 2 is minus 2x, x times minus 5 is minus x root 5. Minus 2 times x, minus 2x. Minus 2 times minus 2 is this plus 4 here. And minus 2 times minus root 5 is plus 2 root 5. Negative times a negative is a positive. And root 5 times x is x root 5. And root 5 times negative 2 is negative 2 root 5. And on the end, we have a positive times a negative, so it will be negative root 25. And root 25 is this 5. That's 9 terms. We can count them as 9 terms. And we've got some offsetting. These 2 terms offset. These 2 terms offset. So they go away, so to speak, vaporize. And what we get is minus 2x is minus 4x. And we got 4 minus 5 is minus 1. And it's boiled back down to this. And all we need to do is take this point, plug it in here, and figure out a. Subbing in 1, 8. Y is 8. X is 1. Doing the arithmetic. A equals minus 2. Because 1 minus 1 is 0, and we got minus 4, divide by minus 4, 8 divided by minus 4 is minus 2. So we claim that the equation is, that fits this bill, we claim the equation is this equation with a equals minus 2. So it will be minus 2x squared plus 8x plus 2, because if you put minus 2 in here for a and multiply it out, this is what you get. Now we could go to the software and see if it passes, but how could you tell by looking if the x-intercepts were actually 2 minus root 5? So we'll check this one using algebra, bringing the example forward to check. Check. Okay, if this fits the bill, then f of 1 must equal 8. Let's check. F of 1, plugging in 1, 1 squared, 8 times 1, do the arithmetic. This is minus 2 plus 2, 0, so we got 8. So f of 1 does equal 8, which is what was required. And to check to see if the x-intercepts are in fact 2 minus root 5 and 2 plus root 5, we'll have to use the quadratic formula to check the zeros. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just see. Negative b, so it'll be negative 8 plus or minus the square root of 8 squared minus 4 times a, which is minus 2, times c, which is 2, all over 2a. And a is minus 2. Doing the arithmetic. A negative times a negative will be positive, so this is why this is plus. And 4 times 2 is 8 times 2 is 16. And 2 times minus 2 is this minus 4. Simplifying further, 64 plus 16 is 80. And we can divide or multiply top and bottom by negative 1. That's why negative 8 became positive 8 and negative 4 became positive 4. Every single term got multiplied by negative 1 across the top and across the bottom. Now, when you multiply this term by negative 1, we just multiply the coefficient on this radical. And when you multiply this one by negative 1, all that happened was plus and minus switched places. So really nothing happened when we multiplied this part by negative 1. But each of the other terms got multiplied by negative 1 for the purpose of simplifying. Now, in this very unit of math, we have reduced these radicals. Root 80 is root 16 root 5. And root 16 is the number 4. And now we can divide each and every single term in this expression by 4. So this becomes 2 plus or minus root 5 over 1. So 2 plus or minus root 5. And this is what was required. 2 plus or minus root 5 is supposed to be the zeros.